All right, we're going to continue these notes here. I'm going to go, we're just going to revisit this. We've already talked about this, how if you to find the derivative of an inverse function, okay, these guys are inverses of each other. We know that when we compose them, they should equal x in order, by definition, to be an inverse. And looks like here, if I plug my input for one function will be the output of the other, and vice versa. All right, so to find the derivative of the inverse function of the output of the original, which is the input of the inverse. Okay, it's a little tricky, and that's why we're going to revisit these tables real quick. We find the derivative, and we've already done this actually. Okay, and there actually is no typos here. There is a typo on the next sheet that we'll get into in a second. So let me brighten this up actually. All right, so now we have, we've got this table, and we want to find the f prime of -1, where g of x is the inverse of f of x. Okay, so the way that this is going to work is that if you want to know g of x, well then you are given that it's an inverse, so therefore, if I wanted the point, it would be that. It would be the output is its new input, its old input is its new output. Okay, I'm going to stop saying that. I think you guys get the drift. Okay, so these guys have been swapped. All right, now if we want prime, what we're saying is we are saying that it is 1 over the derivative of the input, okay, the original input. So if I want g of prime here, okay, I'm going to take 1 over this guy for g of 5, okay? So g prime of 5 would be 1 over 0. All right, now 1 over 0 does not exist, okay? So it would be like 1 over 0, okay? Now, for this guy, we are looking here because actually our original problem wants to find g prime of -1. That g prime of -1 is not this guy. That would be f prime of -1. We would go here and put 6, okay? What we need is this guy because remember our g has been switched. He is the inverse, okay? So this is the guy that we actually want to look for, okay? He's the target. And so if I know that that is the derivative of the original function, g prime at that location, okay, of -1 actually equals 1 over -4, okay, 1 over -4, which is the same as saying -1/4. Okay, so we're actually done. Okay, that's our answer. But if you wanted the inverse here for g prime of +4, it would be 1 over 6. Okay? So that's how you read the tables. Very careful. You got to be very careful with that. I really like to put these points here so I can make sense of what my input and outputs are. Okay. All right, so here you have an equation. So now we're looking for g prime of -9, and this is my original function. So what we want to do is we can, well, we need to set this. We want to know if this is the input of my inverse, it has to be the output of this. And so this means that f of x has to be -9 because that would be my input. I'm sorry, my output here is my input here. So what are we saying? We're saying that 4x to the third plus 5x has to equal 9. Okay? And then that way we know what my output is for this guy because right here he is my input is -9, but for I think I'm just talking in circles. I'm saying the same thing. Okay, we want to make this guy our output for our first function because he's our input for the inverse. Anyways, what we got to do is we got to solve this. Okay, because if he is negative 9, we need to find the x value. No, I'm sorry, plus 9 equals 0. Okay. All right, so we are in a situation where we have a cubic, and so all you have is you either have grouping or you have the rational root theorem. And so the rational root theorem, you would have to actually multiply these guys and figure out factors of 36, and then you'd have to test each one, and boy, is that annoying. So let's pretend that we tried 1. Okay, let's try 1. 4, and then we're missing a square, so then it goes 5 and 9. Oh, wait a minute, these guys kind of add up to 9, don't they? What if, oh, wait a minute, just by looking at this, I actually, well, 1's not going to work, but I think negative 1's going to work. Because if this is negative 4 plus 5, negative 5, then that's going to give me the 0 that I need. But let's try the 1, okay? That's going to be 4. That's 4, 4, 9, and then 9, that's going to be 18. But if it's negative 1, that's going to make him negative, positive 9, and then that'll become negative. There's my 0. Okay. So it looks like what I've got is I've got x minus 1 times 4x squared minus 4x minus 9 has to equal 0. All right, now this guy could be further condensed, but if he's 1 to 1, because if he has an inverse, if he's 1 to 1, then this means that I'm only going to have 1, 0. Okay, now the point of saying this is that he's only going to hit the x-axis one time. Okay, he's only going to hit the x-axis one time. You could try to factor that, use the quadratic formula, but you are going to find that he does not hit the x-axis at all, okay? It's just going to be 1. Okay? So, oh, wait a minute. That means, oh, that has to be the opposite there. Right, okay, because we know actually negative 1 works. Okay, so this means then that my A, what I'm putting forth in here, okay, is a negative 1, and my B is the negative 9, okay? Now we're kind of looking backward to here, okay? So what I want is that if the inverses have reciprocals, okay, reciprocal slopes at f of negative 1, okay, all right, then what we do then is we find out what the f prime is, okay? So find f prime, and it is just the derivative here. That's 12x squared plus 5. Okay, so now what we can do is we're going to go ahead and plug in a negative 1 here. Okay, we're going to plug in a negative 1, and this is going to allow us to find the slope. We found the point, now we need the slope. So the slope at negative 1 is 12, plug that in, squared. That's going to give us 17. So what is the slope at negative 9? Well, if this guy's an inverse, which we were told at the beginning, then we say it is 1 over 17. And that's our final answer. Okay? Voila. Okay, all right, so we got a couple more. Nope. Okay, so we're going to go ahead. This uses technology. I would rather use the graphing calculator when I get back. So I will hold, let's see where we at. We're at the 10-minute mark now. So what that means is I would like you guys, let's look at some more problems here. Okay, well, okay, we'll stop right there. And what I'm going to do is I'm going to hold off on this. I'm going to give you something else to work on. All right. So that should keep you busy. And here we go. Keep you sharp.